So the third part is anisole on reaction with hydrogen iodide gives phenol and CH3I as main products and not iodobenzene and CH3O. So in anisole, on protonation, methylphenyl oxenium is formed. So the bond between oxygen and methyl is weaker than the bond between oxygen and phenyl. So this is because the carbon atom of phenyl is sp2 hybridized, and also it has a double bond character due to resonance. So the bond between oxygen and phenyl carbon is stronger than the bond between CH3 and oxygen. Hence, when in presence of Hi, the iron negative ion, it attacks. So this leads to the breakage of oxygen CH methyl bond and not oxygen phenyl bond. So we get phenol and CH3I as main products. So the next question is, write one reaction of D-glucose which cannot be explained by its open chain structure. So here we will see a lot of reactions that do not explain the open chain structure of D-glucose. So first one is, despite CHO group, it does not react with sodium bisulfite. Secondly, it does not even give 2,4-DNP test and skips test in spite of having an aldehyde group. Third, the pentaacetate of glucose does not react with hydroxylamine. This indicates that there is no CHO group. So, these three reactions cannot be explained by the open chain structure of D-glucose, that it does not react with sodium bisulfite in spite of having an aldehyde group, which we know a D-glucose has. It does not give 2,4-DNP test or skip test, which are a primary test to detect aldehyde group. And the pentaacetate of glucose does not react with hydroxylamine. It clearly shows the absence of a free CHO group in D-glucose. So the second part of this question is, what type of linkage is present in nucleic acids? So phosphodiester linkage is present in nucleic acid? So we come to the third part. Give an example each for water-soluble vitamins and fat-soluble vitamins. So the examples of fat-soluble vitamins are vitamin A, D, E and K, and water-soluble vitamins are vitamin B and C. So the next question is, calculate boiling point of solution when 2 gram of Na2SO4, which has a molecular mass of 142 gram per mole, when 2 gram of Na2SO4 was dissolved in 50 gram of water, assuming Na2SO4 undergoes complete ionization. So we know that weight of the solute is 2 grams. And molar mass of solute is 142 gram per mole. Now the weight of solvent is 50 gram, as we have used 50 gram of water, and Kb is 0.52 Kelvin kg mole inverse. Now, since Na2SO4 undergoes complete ionization, I should be the number of moles of ions Na2SO4 gives. So since Na2SO4 on complete ionization gives 2 moles of sodium ion and 1 mole of sulfate and ion, so I, that is the Van't Hoff factor, should be 3. Now, since there is an elevation of in boiling point, the delta Tb is I into molar mass and into Kb. So I into Kb into molality of the solution. So I is 3 and Kb, and molality of solution is moles of solute divided by the weight of solution. So it is so putting the values here, it is 3 into the number of moles of solute will be 2 over molar mass. Kb's value is 0.52 into 2 over molar mass, that is 2 over 142, into the weight of solvent, that is 50 into 1000. So the delta Tb comes out to be 0.43. So boiling point of solution should be the excess boiling point plus the initial boiling point of water. So boiling point 100 degrees Celsius plus delta TV, that is 100 degrees Celsius plus 0.43 degrees Celsius. So it is 100.43 degrees Celsius. So we have found out the boiling point of the solution in when 2 gram of sodium bisulfate was dissolved in 50 gram of water, assuming sodium bisulfate undergoes complete ionization, and boiling point comes out to be 100.43 degrees Celsius. So the next question is, first part, name the method of refining which is based on the principle of adsorption. So the answer is chromatography. So chromatography is a method of refining which is based on the principle of adsorption. The second part, what is the role of depressant in froth flotation process? So it is possible to separate two sulfide ores by just adjusting the proportion of oil to water, or simply by using depressants. For example, in case of iron ore contains zinc sulfide and lead sulfide, and the depressant which is used is sodium cyanide. So it selectively prevents zinc sulfide from coming to the froth but allows lead sulfide to come with the froth. So with the use of depressant, we can selectively allow some sulfide O to come with the froth and other do not, and in that way it helps in the froth flotation process. Now the third part, what is the role of limestone in extraction of iron from its oxides? So I will write the chemical equation. So the limestone provides this calcium oxide for the decomposition. So calcium oxide, which works as flux to remove the impurity of silica as slag. So the limestone on decomposition is providing calcium oxide which acts as flux for this impurity silica, and that forms slag. So actually limestone helps in the extraction of iron from its oxides by removing the impurity of silica. So the next question is, define the following terms. The first part is OW emulsion. So OW emulsion is a type of system in which water acts as dispersed medium and oil acts as dispersed phase. Example of it is milk or vanishing cream. So in milk, liquid fat is dispersed in water. So water is the dispersion medium and liquid fat is the dispersed phase. So the second part, what is zeta potential? So as we know, separation of charges produces a potential. So the charges of opposite signs on the fixed and diffuse parts of the double layer results in a difference in potential between these two layers. So there are opposite charges that result on the fixed and diffuse part of the double layer. So these separated charges produces a potential between these two layers, the fixed and diffuse layers. And this potential difference between the fixed layer and the diffuse layer of opposite charges is called zeta potential. So the potential between these fixed and diffuse layers is zeta potential. So this is what zeta potential is. Next, we come to the third part of this question, multimolecular colloids. So when a large number of atoms or molecules of a substance aggregate to form a very large species, somewhat of the size larger than the colloidal range, the species thus formed is what we call as a multimolecular colloid. So large number of atoms or molecules combine to form and these species are what we call multimolecular